Today we will be taking T-notes on the Earth's movement in space in relation to the Sun. The Earth moves in two ways in relation to the Sun. It orbits the Sun in a counterclockwise motion, and it spins on its axis, which is its center point, also in a counterclockwise motion. Counterclockwise just means if you're looking at the face of a clock, the natural direction that the hands go counterclockwise would mean that it would go in the opposite direction. So here we have the Earth spinning on its center point from left to right, so in the counterclockwise motion, and then around, it is orbiting around the Sun in also a counterclockwise motion. Let's just get this into our notes. Rotation is spinning on its axis. This is spinning on its center point. Revolution, on the other hand, is where the one object is orbiting or moving around another object. And you don't have to draw this again. I was just using this so you can remember from looking at the earlier diagram that you drew which one is rotation and which one is revolution. One full revolution of the Earth around the Sun causes day and night. This full rotation is 24 hours that it takes in order to get all the way back around, and we experience one full day and one full night. So remember here that we have the axis point is straight through where the red line is, and we have a tilt. There is a tilt of the Earth about 23.5 degrees, and here we have the spinning in the counterclockwise direction. Now, when there is sun lighting the Earth, and let's say the Earth is on this side of the Sun, the Sun's rays are going to be hitting one side of the Earth, and this is the side that will be experiencing what we call daylight or daytime. The other side, which is shrouded in darkness because it does not get the light, this is what we call nighttime. This full rotation that takes 24 hours is going to cause the sunrise all the way through the daytime to the sunset and then nighttime. One full revolution of the Earth around the Sun, however, does not cause day and night. This is what we call an entire year. So 1 year, one full revolution around the Sun takes us 365.25 days. Now, what causes seasons are two things: the Earth's tilt on its axis at 23.5 degrees to the right, and the Earth's revolution around the Sun. So these two things together cause the changes in the season that we see in the northern and the southern hemisphere. Please draw this diagram. You do need to show north and south hemispheres. And so here what we see is the Sun positioned in the center of the orbit that the Earth would take around the Sun in an entire year. And notice that it is more of an elliptical orbit and not a circular orbit. And the Earth is placed at 4 different points around the Sun, showing the 4 different locations throughout the entire year. And so let's start over here with the Earth being to the right of the Sun, where the northern hemisphere is pointed more away to the right. When the Sun's rays are hitting the Earth, you're going to notice that more of the Sun's rays are directly hitting the southern hemisphere. Because of this, the southern hemisphere will be getting more direct sunlight, more access to direct thermal energy that is entering the Earth at this point. Therefore, this is going to warm up a lot quicker than the northern hemisphere, and therefore, this northern hemisphere is going to be colder, experiencing winter, and the southern hemisphere is going to be experiencing summer. As the Earth moves around the Sun to this point right here in the year, now we have where the Earth is still tilted in the same exact direction of the 23.5 degrees to the right. But what we're noticing is now with the Earth coming closer, and both sides are now equally receiving light, we have the northern hemisphere warming up, which is what we call spring, and the southern hemisphere is now getting cooler. And so it's not getting as much direct sunlight as it was down in this location and in this orientation. So now the summer is turning to fall in the southern hemisphere. And then as we go further along, here now we have the northern hemisphere mimicking what was happening in the southern hemisphere over here. The northern hemisphere is facing more directly towards the sunlight and therefore getting warmer and experiencing summer. The fall in the southern hemisphere will start to cool down even further because now the southern hemisphere is pointed further away. It is now experiencing more indirect sunlight and less of it. So here we have winter. And then as it goes further along to complete its journey throughout the year, we have the northern hemisphere and the southern hemisphere both at equal distances from the sun. And so the northern hemisphere that was experiencing summer will start to cool down and not get as much direct sunlight, therefore experiencing a change of season into fall. And then the winter that was down here in the southern hemisphere will now start to warm up because now it's getting a little bit more direct sunlight from the sun in this point. So as the Earth revolves around the sun at various points, it is all about how much direct sunlight each hemisphere is getting, and that tilt makes that possible to achieve differences in temperatures and seasons in either of the two hemispheres. All right, we've reached the end of our video T-notes. Please make sure you understand this information and that you got all the diagrams, and look forward to seeing you in class next.